One of the things I did when I first saw about the oil spill is I discussed with NASA about getting a plane down there to make a map of what the coastline looked before the oil got there. And that's what I'm going to talk about a little bit today, to get a before picture, because how can you clean up the environment, put it back to where it was if you don't know what it was to start with? Okay. However, yesterday, the DOI, Department of Interior, finally released the numbers from our group. I'm on the technical flow rate team, trying to figure out how much oil came out of the seabed. And the numbers were 62,000 barrels per day, which, as it so happens, was exactly my number. Interestingly, the number I came up with, 62,500, and that was the number that came up with. I had a range on it, a range from around 40 to 84, did a mass balance estimate, and also from the video at the seabed. But it has, how do I say this? It's been so frustrating. That's probably the best thing. It's been a nightmare. There's been this thing, how much oil is coming out? The question continuously, how much, this all the way time for me. And the real point is, shouldn't have this question. There should have been monitoring systems on the seabed put in place right when the spill happened, so we wouldn't ask the question how much oil, we would know. This was one of the recommendations of the 2001 deep spill experiment. There was this planned release experiment in Norwegian seas. They released some oil and gas, and it kind of came up, and they tried to study, and they had weather problems, and they ran out of money, and they didn't learn an awful lot. And so, since we didn't learn a lot, we're now asking questions, where is the oil? And I started trying to say, not only where is the oil, why is the oil going where it is? Do we understand what happens in the deep sea? And the answer is resoundingly no. I mean, why is there a deep sea plume of oil? And we don't know. And I actually couldn't tell you the answer. I have some ideas. Early on, and this is, I'm sorry, I'm being a little scattered, but early on I proposed putting a monitoring system in place, early on being like day 5. And because of my role in the remote sensing, I proposed this. I tried once getting through BP's thing, and nothing happened. So I went to the head of remote sensing at BP and said, could you pass this to people? And it was silence. So I then said, when I'm in the technical flow rate team, I have this plan to measure the flow, so we don't have to use crappy BP data, where by crappy, I'm really overemphasizing how lousy it was. Okay, imagine if you want to be obstructionist, for example, you have your video from your ROV. It's really nice, high definition quality, and you put it on your computer monitor. Then you get your cell phone camera, and you point it at the computer monitor, and you take that picture, and that's the video you provide to the scientists who ask for it. But of course, it's not that good because you make it a little blurry. So I could actually see the outside of the monitor in their video, a little bit blurry. And to make it really good, because you're British, you use PAL, and you make your video camera in American, so it skips a frame every 10 frames. And he said, and so what ended up happening at this point is that this is ridiculous. You may have seen, but at that point I went on CNN, and Wolf asked me, so Dr. Leifer, can you tell us how much oil's coming out? I said, I wish I could, but I can't because I don't know. BP is providing us really crappy data. And so given that I don't know, and there's no data, and there's no monitoring system, what I did is I said, well, let's use BP's number. Their oil spill response plan has a worst case number in it. Pipe coming out of the seabed looks worst case to me. If they don't like their number, then let them give us the data. Their number was 100,000 barrels a day. They didn't like their number. We got the data 2 days later. Congressman Markey wrote a very nice letter, well, not nice, to BP, and suddenly they were forthcoming instead of giving us the runaround. I mean, it's hard to believe because this is what happened, but we said, can you get us the data there? We don't know. The video is on some platform offshore, and it'll take us 3 or 4 days to find out which platform. And you start going, really? And you make $17 billion last year, but you can't find something when okay. So again, very frustrating because we weren't getting data. We couldn't figure out what the flow was coming out, which was needed for a safe response. So after a while, I presented the experiment to the presidential task force. Nothing happened. I came up with, you may have seen, the Deep Spill 2 experiment. I said, while this is going on, while we have the tornado tearing apart houses, metaphorically, why don't we actually study it so we can learn something for the next accident? and it never really happened. And the idea, I guess, is that we'll learn from this after the fact. We'll do forensics on all the data that was collected. And so this was kind of the situation that's been turning my life upside down for months now, is trying to be able to do the job, and finally we've been able to release the numbers, and so can talk about that, and happy to answer questions about that later. So I have a talk about NASA. Okay. What you can see, there's the well blowing and the center and the team, and we're using remote sensing to figure out how thick the oil is. One of the, and you can go to the next slide, but one of the advantages of living here in Santa Barbara is we have a natural oil spill for science all the time. We can actually learn from this, which allowed us to figure out this methodology with colleagues at USGS. Okay, next. And try to figure out what was happening using this new technique. So, you know, the fact that it kept blowing and blowing after months was just very disarming. Now, one of the things you can notice is some of it's light and some of it's dark. There was sort of fractionation. So you get hydrates, the white stuff at the top, and it's much oilier. It's a very difficult problem to study from the video. And we tried to figure out velocities from this to get flows, but we had to guess what's happening inside. So from the number that you're hearing on the news, there's a lot of guesswork on how a plume behaves, and we really don't know. So there's a lot of uncertainty in that number. Now, okay, and next one. Okay. Watching the slick on the satellite data, looking very closely, it's also really clear it's not been an even process. So initially, the slick grew very fast, a couple of days, then it kind of slowed down and grew slower. And then about a week, 10 days later, it suddenly started growing very fast. You may have seen the thing that looks like a hurricane on the sea surface. Right about the time they took the Coffer Dam down and used it as a battering ram on the well. Okay, I don't know if there's a relationship, but it wouldn't surprise me. Now, at that time, they put this Coffer Dam down on the well, and I had bets with my colleagues. I said 40 minutes before it hydrates up and useless, and one of my colleagues said 20 minutes. I think it lasted about an hour. Because we've tried this. We've tried this in the deep sea for science, and we've had these problems. Of course, no one really asked our advice, which was given. After they didn't ask that, I then pointed out that they have to be very careful when they lift it up, because it's going to be filled with hydrates with methane, but also sulfur and oil. It's really toxic gases. If they're not careful, someone would die. Now, let me rephrase that. One of our scientists on a cruise, we captured some hydrates, brought onto the boat, was in the cool room. The door was closed, which was a mistake, and we came across her passed out from the fumes. Think about another 40 seconds, she would have been dead. Okay, the gas that you see at the seabed, you can go to the next, is not nice stuff. Okay, here you can see the oil on the grass, and then right next to it, you can see grass that's kind of flattening over. That oil doesn't just stop where you can see it brown, it goes through the dirt. It kind of seeps through so the roots of nearby plants, they're just on borrowed time. Okay, and some areas obviously have already been killed off. You go next one. Not only is this much larger than the Exxon Valdez or much larger than the Santa Barbara, but this coastline is much more complex. And, okay, I'm just going to hit another topic. Where's the oil going? According to BP, it's all gone. It just disappeared. Well, the reality is we know oil doesn't disappear. We get to see it every day, and it sort of goes somewhere, and it doesn't go away. It turns out that what's happened recently is a really nice loop current. So there's the Gulf Current, which kind of comes up over Cuba, around Florida, and up along the coastline. And every once in a while, it spins off into a loop current. And the last 4 or 5 days, that loop current was going at 2-3 meters a second, really fast. It was just spinning the oil around. And as it so happened, the place it was dumping is Barataria Bay, where no one was looking for the oil. The latest satellite data showed that, and we had the NASA plane took some data just recently, shows a lot of oil, which also has been showing up in some of the media. It's a little bit soon to say the oil's all gone. And I mean, there's also been some media critics who will say, not media, but media personalities who said, well, the microbes are eating it all up. If you hear someone say that, just either assume they're underpaid or they're paid by BP. It's silly, okay? Because there's no way that microbes can make oil just go away. If they could, we'd be in our oil-free future in about 2 weeks because all the oil in the plant would be gone. It's not the way it happened. The oil just does stay around. Okay. One other thing on this one. One of the big worries that I think people have started to look at, but not in detail, it's not really the pelicans that we're worried about most from the oil, but it's the food chain. If the oil is killing off the phytoplankton and the zooplankton, then the whole thing could be a slow motion collapse that reaches pelicans that are cleaned and released